Hi everyone, welcome to this edition of Tech Spark. Joining me today is Brian. He's our engineering manager,
Hello.
and I am Kai. I'm the product manager at Meanwhile USA. So our topic today is going to be on high voltage DC applications and products. And Brian and I are very excited to share with you guys about HVDC because we're going beyond the realm of SELV. We're going to the dangerous voltage zones, and we're getting more and more inquiries about the high voltage applications in recent years. And Meanwhile has started to release more and more of these high voltage DC products. So let's jump right into it. So Brian, can you tell us like what kind of HVDC products Meanwhile we have to offer to the market right now?
Okay, so I'm showing on the slide. So today we have two different kind of HVDC. When we talk about HVDC, high voltage DC, there's input to it and then there's output to it. So in terms of output HVDC, we currently have high power, the UHP 1500 and then 3000 watt, 15 kilowatt and 30 kilowatt. Okay, either single phase or three phase, conduction cool or fan cool. So those we have all the way up to 420 volt DC output. Okay, so we have 115, 250, and 420 volt DC output, fan or fanless, and 1500 to 30 kilowatt. That is the current offer for the HVDC output. Okay, for the input side, we do higher. Okay, we have 150 volt DC up to 1500 DC. And the power is 10 watt all the way up to 300 watt, either in a thin rail form or enclosed form. And we recently just released an inverter, okay, that can also take DC input up to 420 volt, wow. Okay, for other higher power AC, portable AC application. Okay, so those are two HVDC products that we currently offer. Okay.
Yeah, and you mentioned like we have fanless products, right? And I think water cooling has also been a very hot topic in recent years. So in terms of our high voltage DC output products, what's the highest level of power we can offer that is a water cooled product?
We have 7.5K is the highest power rating for water cool. Actually, the 10K, the three-phase input,
right? Yeah.
also do water cool as well. And more application, for example, popular now is AI, and it's used a lot of power from the data center. And data center now are more moved toward water cooling to reduce heat. Okay, they want to they don't want to use fan cool because fan pushing the heat out, heat up the entire room. Water cooling is the trend right now for AI.
I see. So it seems like we have a wide range of products for the high voltage DC input and output. So Brian, can you tell us more about what kind of industries these products are used for?
Okay, sure. So the first one is the HVDC input. So popular industry is green. Okay, so I showing on the slide three photo. The first one is solar. Okay, it's for solar farm where the solar array can add up to like 1200 VDC, and customer use our RSDH 150 300 to drive the motor. Okay, the motor then in turn would turn the solar to jack the sun to maximize efficiency of the entire solar farm. And the second one is the wind turbine. Okay, wind turbine, they usually output 800 to 11 VDC, 1100 VDC. And customer usually have an inverter, okay, a three-phase output inverter that take 800 to 11 VDC and invert to generate power. And they also need an auxiliary power, that a DC to DC converter that can take 1100 VDC and convert to like 24 volt, 48 volt to power some of the auxiliary power like control board, a DC fan that is isolated from the inverter for safety purpose.
I see.
Okay, and the third one is energy storage. Okay, energy storage battery voltage could be up to 1300 VDC, and same thing. Customer one is to use an isolated another DC to DC to step down the voltage for control. For example, control board or the user interface. Okay, someone like want to do touch screen stuff. They need to have another DC to DC isolated converter.
So it seems like customer needs like the low voltage 24, 48, 12 volt for the motors, auxiliary controls, and all that. Why can't the customer just use a traditional, AC to DC power supply? And why do they, choose to use a high voltage DC instead?
It's cost saving. I mean, they don't want to do because those applications, basically DC, AC are not really available. Like, so for example, solar, if they want to bring AC in, they have to do another conduit and pump the power in. And then turbine, obviously, wind turbine, you don't have AC available. So DC is their first choice. If there's no choice, then they would go with AC.
I see. So it seems like you can eliminate the AC wiring to these remote locations, and you can also, save costs on the, maybe like a AC generator or something. So you just use the DC that's readily available there, and then you can power these devices.
Yeah.
I see. And are there more for the output?
Yeah. In terms of high voltage DC output, okay, what we've seen so far is the number one is centralized power. Okay, it could be used for grow room or retail store. The point here is that large grow room use a lot of AC to DC power supply for each fixture to reduce the total weight on the grow room and also efficiency of the entire grow room and reduce the heat. Okay, or nowadays centralized DC is what becoming popular, meaning a high power rack installed inside an electrical room that bring high DC input to power individual LED array. Okay, instead of using a lot of AC to DC power supply.
I see.
And the second one is the level 3 EV charger. Okay, popular voltage is 400 to 800 volt. Okay, and the last one here is the gas 4. Okay, gas 4 power system. Okay, they are ranging from 320 to 360 volt. And so I'm showing on a slide here, what is gas 4? It's a new one. Okay, it's just getting more popular in the last 2-3 years. It consists of a transmitter and a receiver. Okay, the transmitter and receiver is sending a pole chain of signal. When there's a fault, it's going to shut down the power immediately. Okay, it's so I will go more detail into it later, but the point here is that gas 4 require high DC voltage as well, and it's safe and a safe cost for installation.
Okay. I see. So it seems like class 4 is the a hot new topic, and it's the best thing out there right now. And we haven't really heard much about it before. So Brian, can you tell us a little bit more about what class 4 is and why we care about it?
Okay. So before going to gas 4, so gas 4 is basically what it's called a fault managed power system, meaning when there's a fault, it's going to shut down the power immediately. Okay, and so we before we go to gas 4, we usually heard gas 2. Okay, for lighting, people want gas 2, and then there's a gas 1 and gas 3. So gas 1 and gas 3, they are require different voltage. So gas 1 is like 600 volt, like building wire. Okay, it requires electrician to do the installation. Okay, gas 3 is a higher voltage but lower power. It still require electrician to install. Okay, and require conduit. But the wire gauge can be used only 24 wire gauge.
I see.
And so gas 2 is very popular, and you see gas 2 is used a lot in PoE lighting. Okay, because it does not require a technician to do installation. You can do you save the cost there, and gas 2 also save cost for application where the PCB layout, the enclosure do not need to have higher power rating. Okay, and so gas 4 is the same. Gas 4 offer the same as gas 2, and it's even better. Okay, because the bus voltage is up to 450 volt. Allow up to 450 volt, and power transfer can go up to 600 watt per cable, per copper cable. And a lot of applications now use gas 4 like PoE, lighting. Okay, a smart building, those are use gas 4, and the wire gauge, the wire is used like you have to use special wires, 16 to 18 gauge to deliver power. And important is that it can do long range up to 2 kilometers.
Oh wow!
Okay, it can do typical up to 2 kilometers as compared to like 300 meters from gas 2. And so So when there's a fault, okay, Glassfall is a file manager system. When there's a fault, it's basically shut down the entire thing. And here is how it does the fault that it does to it. Hold on a second, my slide. Okay, here is the how the Glassfall do for the safety. Okay, we have this they are GFCI where detect line to earth leakage too high, it shut down the power. AFCI it detect any arcing. Okay, but Glassfall can do both.
Wow.
Okay, basically it cover both. So if there is a line to earth high current, it's gonna shut down. When it's arcing, it's going to shut down. Basically, what it does is superimpose a high frequency signal on top of the DC voltage. Okay, and that signal keeps sensing. If there is an abnormality, okay, it basically shut down the whole system to make the whole system safe. And so one is proved to be safe. Then it does not require conduit. Okay, the whole thing is you don't have conduit to do the installation.
So it can transmit at high voltage, transmit long distances, very high power, but the safety requirements is even more relaxed than or same as a class 2. Like you don't need an electrician, you don't need conduits.
Correct.
That sounds too good to be true. Is that because it has a lot of this very hard safety certification requirements and all that? Can you tell us a little bit more about the requirements to get the safety certified?
Yeah, so Glassfall is now it's already in the NEC National Electric Code. NEC have it written in 2023. In 2023, and UL also released a standard for Glassfall already. So for the entire system, okay, that consists of a transmitter, receiver. Okay, it's under UL 1400. That's one. Okay, the cable, the 16 gauge, 18 gauge that used to carry the power, deliver the power, is gonna need to evaluate under UL 1400. Okay, and for the peripheral, for example, the transmitter, the receiver, the power supply, okay, they are all need to be under UL 6236A. Okay.
So let me just reiterate that to see that I understand it correctly. So the components, like the power supplies, the transmitter receivers that make up the fault managed power systems, those are evaluated to the UL 6236A safety.
Correct.
And then the whole system, the system as a whole, would be evaluated to the UL 1400. So if a customer asks us if meanwhile we can do UL 1400 on our power supplies, I think that answer would be no, right? Because it's evaluating the whole system.
Correct.
I see.
Yeah.
I see.
And so I'm going to show another slide here. It's going to be more easy to understand. So for the entire Glassfall, okay, it's basically have a transmitter and a receiver. The transmitter needs power to power up. The receiver needs power to power the end device. Okay, so in terms of the AC to input side, what power the transmitter is, because they need a DC voltage up 320 to 360, okay, to power up the transmitter. The transmitter then take that voltage and impose a high frequency signal on it to the receiver. Okay, so for the transmitter side, popular model is the NCP 3200 rack power, okay, or the HHP 10K, 30K, 380 volt, and the RST 7K, 7K5 and 15K. Those are the 380 volt that the transmitter need. Okay, it can do. We have single phase, 3-phase power that can be used to power the transmitter. And after that, okay, the transmitter get power and send the power to the receiver. The receiver side also receive the same voltage. Okay, maybe a little bit drop to the wire. And the receiver would also need another step down power supply to step down from 320 volt, 360 volt down to either 1224 to power the light fixture or the PoE. Okay.
I see.
So in terms of receiver side, we have the DIN rail power, the DRX, the RSDX that can take can take 150 to 1500.
Yep.
Okay, and the inverter. Okay, the inverter can also take the 320 volt out to AC as well. So
okay, I see. So I think so for these are the suitable meanwhile products that we can offer to both, the transmitter going inside the transmitter or going inside the receiver, but they don't make up just a transmitter or receiver, right? From my understanding, we work with a couple of customers that, their IP, their company, they focus on the transmitter and receiver technology. But to power those transmitter and to power the receiver, they would need power supplies that provide the high voltage DC. And that's where Meanwell comes in, and we provide, both the high power for the front end transmitter and also the lower power for the receiver end.
Yes.
Yeah.
Yeah. I mean, we play like ballpark front end and the receiver, and they both need an AC to DC and a DC back to a DC.
Yep.
Okay. For the end device. And one more thing is that besides safety, save cost of the class 4, it's also the smart building, meaning you can control and monitor. You can do easy to do maintenance. You can shut down one line if you want. You can shut down two if you need to do maintenance or make change to it. That's another advantage of using the class 4.
Because some of the our customers, I cannot go into too details about their technology, but I think they also, have some communication over the class 4 transmission. So it is data plus power. So they can really make a very smart system. All right, so we talked about class 4 and all the HVDC. Can you give us some case sharings on high voltage DC applications in general?
Yes. So the first one is the high HVDC output centralized power. So this application, like I mentioned earlier, instead of using a lot of AC to DC power supply in the grow room, they use like a rack power and then have 12 XP 10K 380 volt output inside an electric room. And then they have multiple of the cabinet, and all they have to do is they bring the DC voltage into the grow room to power 10, 20 lights. And that way you can make it the entire grow room more efficient, less heat generated, and easy to do maintenance.
Yeah.
Okay, and the XP 10K also has the PC function for dimming and also on-off control. So it's a good that's what is called centralized power.
I see.
Okay.
I see.
And the next one is the also high voltage. Okay, application here is for energy storage, where they have to cool or regulate the battery inside the container, so that they are building a compressor, a high voltage DC compressor that about 8 kilowatt. Okay, so they need an AC to DC to power the compressor to generate the heat and or cooling the battery, so that to keep the battery at the regulated temperature.
The high efficiency range that the battery is operating, right?
Yeah, I mean, because battery is lithium-ion battery, especially when it's too cold or when it's too hot, they won't be able to fully charge or fully discharge. Okay, so it's better to keep them at from between 25 to 40 C. So that's why they have to the customer have to decide. They basically design their own cooling system. Okay, one container like you choose XP 30K to power 2 cooling system to regulate the temperature.
That is cool.
Okay, and so the next one is the wind turbine, like I mentioned earlier. Okay, the so customer here, the turbine output is up to like 2.5 gigawatt, and the DC voltage is 800 to 11 VDC. And so they have a 3-phase. They design their own 3-phase inverter. Okay, to power to convert the wind turbine voltage to AC. But they also need another auxiliary power. Okay, a DC to DC that can power the fan for the inverter and also the controller.
That's the RSDH was chosen, and I think in the other designs or previously they would have to have like a generator of sorts to power like a power supply, right?
Correct. Yeah. Otherwise, I mean, they of course, if they can do the inverter, they can do another DC to DC, but they prefer to get something off the shelf. Okay, with potting compound, because the unit we offer here is not also suitable for outdoor use. Because it's semi-potted. Okay, that's what they really want, because it's installed outdoor in a desert somewhere, the moisture environmental factor that they have to consider.
Yeah, that looks like a very harsh environment. All right.
Okay, let's get to the last one here. Okay, so this is we just talked about the glass floor. So I'm gonna go over it again. So what in the box you see is the glass floor. It consists of a transmitter, okay, and a receiver. So from transmitter to receiver end, you will see like 320 volt to 360 volt DC, and then there's an energy package that's coupling that superimposed on that DC to detect any fault. Okay.
Yeah.
Any fault between the line, any like short circuits or open circuit, it shut down the power immediately. Okay, and that how it make the entire installation safe. So for example, if you want to bring the wire from one building to another building, or from the bottom of the building to the top of the building, in US, you usually have to go conduit because the voltage hazards. With this glass floor system, you can put like one transmitter at one end and then the receiver at the other end. You can just use the regular 18 gauge wire, okay, and don't need to do conduit. So that is going to save a lot of cost for the building, and also you don't even need to have the what's called technician. I mean, a certified technician to do the installation. And so transmitter aside, okay, AC to DC, we have the NCP 3200 380. Okay, customer use 3 units in one rack to power up the transmitter, and they use multiple rack in one 19-inch cabinet, like located inside an electrical room to power the transmitter. And then the other end is the RSD DDR thin well unit to 57 volt to power the PoE. Okay, and then the other one is the inverter. Okay, for other applications like EV charging level 2. Okay, where you only need like 5,000 watt or 10,000 watt for one port to charge to charge the EV. An inverter also the NT and 5K also use.
Yeah, because I think the RSDH and the NTN, because they're designed to be DC input. But I just remember that, meanwhile, the thousands of AC to DC models will also on our spec, say they have the DC voltage input as well, in addition to the AC. So those can be used in specific scenarios too, right, Brian?
Yes. So a lot of AC to DC power supply, you see on the spec is say up to 370, 380 DC or 400 VDC. They all can use. They all can use with it. The only problem is that it's need further evaluation when they do the safety certification for the system. But what we have here is the ISDH and DDRH and then the inverter. They all UL certified already. Okay, it's gonna make it easy for the entire system to get certification.
I see. So we have the standard already that's ready to use, like the RSDH, DDRH, and the NTN. But the other thousands of different models, like whether if a customer needs a IP-rated outdoor, right, they can get the HEP. We can work with them to certify it to DC input to the UL6236A, and then they can use it in their system.
Correct. Yeah.
Okay. That is cool. And so that is something that's very important to keep in mind, that we can, work with the customer to generate a solution. And I think meanwhile, we really are in the position to offer to a lot of these companies that are trying to get into class 4 or in the class 4, industry by providing power supplies to both the transmitter end and the receiver end. Okay. So I think that's the last case sharing for the day. So yeah.
Yeah, just to reiterate, glass 4 is getting more and more popular now. I see a lot of companies sending inquiry over. A lot of companies is developing their own system, even for lighting. They want to do their own glass 4 as well, and that's why NEC approved it, and UL really pushing out the standard to evaluate it. Okay, and in the near future, I think we will see more and more in this.
Yeah. I think it started out as a concept many years ago, but now it's slowly kind of officiated by NEC and UL by releasing these official standards that we can certify to.
Yeah.
Right. So I hope we will see more and more of these class 4 applications in the future. Yeah. All right. So thanks everyone for joining Brian and I in today's Tech Spark. So that's it for the today. And then, but next edition will happen on September 26th. And then the topic will be focusing on the battery chargers. So the meanwhile battery chargers that will provide reliable, efficient power solutions for various applications. All right. So if you guys have any questions, please don't hesitate to contact the Meanwhile technical team or your sales representative for any technical or commercial information. Again, thank you everyone for joining us. We'll see you guys next time.
Thank you. Bye-bye.